Hi, in this video I'm going to make a 3D scan of this bumper of my e-scooter InMotion RS. There are 4 of this bumper on each corner, so the other side is a mirror of this one. So this one will fit into this corner and this one will fit into this corner. I only need to make only one copy of this 3D scan, and then I will reverse in CAD to make a 3D printer friendly version of this part. So this part serves the purpose for protecting the aluminum body when crashing. So when the scooter crash, this bumper will go down first, and it also has exit for power cable for the rear motor and also for the front motor. It also helps supporting the silicone pad to make the footboard looks larger. It also supports, you can see this small turn signal light. So if I want to redesign a new bumper, I will scan this fixing point so that I can design around the existing part. But in this video, I will reverse this one, but not redesign. Actually, this bumper is available in the online store for $60 US, but it's not available outside of the US. So if I break it, then I wouldn't be able to get replacement part. Okay, let's take a look at the point of contact. So this face here will be in contact with this aluminum face, and this face will be in contact with this face, and this face here, small one, will be in contact with the lower part, and this face here will be in contact with the end of the aluminum profiles here. So there are 1, 2, 3, and 4. There are 4 contact points that I need to be careful when making the reverse with the CAD software. Okay, the purpose of reversing in CAD is to make a 3D print compatible version of this part. If you look into the geometry of this part and if you want to print it, I would probably print it in this direction by facing this down. And if you look here, there's some obstruction for the filament to climb up. This horizontal stiffener would require support, so I will remove it. And also this extension, which serves the purpose for aesthetic. There's 2 extension here. It just come up in the air, so we can't print this without support. This 2 extension, I will modify this part so that it can be printed without support. This opening, I would probably need a support because there's no other way to do it without a support. And also I will try to keep the original aesthetic of this part. Before we do the 3D scanning, let's investigate the part a little bit more. This part, if you look from the outside, it may look like that they use surface modeling. There's 2 kinds of 3D modeling in CAD. First is solid modeling, and the second is the surface modeling. The first step is to investigate and find out what did original designer use for modeling this part, and I believe that original designer used solid modeling for this part. Even though if you look here, this face here has 4 corners that's in a different plane. When you look roughly, it may look like that it was designed with the surface modeling, and actually it's not. It's designed with the loft function in the CAD software, which I will show you later. If you use the surface tool and model this one, it will take a really long time and it will be a dead end. You won't be able to finish this part. So first step is just to look into the part and identify the original design process of the part. Some of you may ask, why don't I use the third-party automatic surface creation tool like a Quick Surface or Design X? I would say that this part was created by using CAD with a simple CAD tool. So if you want to reverse it, you need to use the original tools that create this part. Those third-party software is not necessary for me. It's going to take a longer time than using the standard tools in the CAD software. So I will use the Creality Scan Raptor PRO for making this 3D scan. I'll place it on the turntable using the external marker. I will scan in two sides, upper sides, the bottom side, and then I will merge it in the software. So the front and the back of this part share the same wall here. These two side wall will be visible to both scan, top scan and the bottom scan. You see this side wall. So this will be the overlapping area. And I believe that the software can merge this because it has the tapered surface and a bit of the curvature and taper. So I think it will be able to merge this one perfectly. And to be sure, I will add the marker on the side just for use it as a reference when merging. So I need to put like 4, but I can add a little bit more because I'm going to spray this part and some of the marker may not be visible by the 3D scanner. Because this part has deep pocket, I will try to reach the bottom of the pocket and also a lot of crevice. So I will try to get as much surface scan as possible. This gap here is very small. I don't think the scanner projector can reach the bottom of the gap here and also here. So this 3D scan cannot be 100%. So I think I'm gonna get at least 90% of the scan. See here, there's a small gap. There is a gap here deep inside. It's quite deep. So it's best to just use the spray to help it because I can wash this part, it's plastic, and also I don't want to remove this reflector, so I will use the spray to coat it. Okay, let's spray it. Make sure that you spray in a different room from the scanner because the scanner has ventilation fan inside and it will suck in the dust from the spray and it will not come out. So I will use 0.3 millimeters for the resolution. 0.3 will be more than enough. Okay, I will start with the global marker. Okay, here's a global marker. And I will adjust the brightness just a bit. Okay, now it's a bit brighter. Because I use a lot of markers here because I want to scan on the side. And I want to be able to see as many markers as possible. Okay, it's done with the global marker. I start with the point cloud scanning. I will start with the 22 line first. Then I switch to 7 lines for fine details scanning. This is 7 lines. As you can see, that 7 lines can go deeper into the pocket. Okay, thing is done. First scan, I make a new scan to scan the back side. I need to flip this over. Okay, and I will place the markers as close to the object as possible. I click on scan, global marker. I will adjust the brightness for the marker. Okay, now it's brighter. And I start global marker scanning. You may ask why don't I use the wireless handle because if I use a wireless handle, it will clash with the table. So it says if the part is small, it's better to just hold it. So same as before, I will start with 22 lines. Okay, switch to 7 lines. Okay, I think we have everything. Okay, I will process the first scan. Make 0.3 resolution. Okay, now move to the second scan. There's some part that is not scanned here, and some here is not scanned. I think it should be fine for reversing. Okay, let's merge it. Okay, we merge, go to the merge menu. I will use manual merging. Let's try with the marker. Scan 1 and scan 2. So the markers are visible here. Okay, it's visible here as well. So I will pair it 1, 1, 2, 2, 3, 3. Let's go the other side. What? Okay, I can see it. You need to zoom in to see it. There's 2 here and 1 here. Sometimes you need to zoom in to see the marker. See, it's not here. But if I zoom in, you can see it. 4, 4. Let's make it 1 more. 5. Okay, I will start it. Okay, now it's merge. Click yes and exit merging. Okay, now it's the part is merged. So I will export this as the point cloud ASC format bumper tutorial. Next, I'm going to mesh it. We have 643,000 points, so I will mesh it to around that, and I will close it. See how well it will close the missing part. Okay, yes, it's our 3D scan. Outside look almost perfect. See here, almost perfect. Yeah. Okay, look at the other side. Yeah, the software tried to fill the holes here. The one that I didn't scan, and it's replaced with a curved surface. But I think it's fine. Some of the area is not scanned. The software try to fill in. Little rough here on the edge. I think you can possibly just export this to the slicer and just print it. Okay, I will export this mesh OBJ, and then I will send it to Creality print. The part is not coming. Really? Yeah, it doesn't work. It used to work. I mean, click on share and then it will OBJ files. No issue. So I will face this one. See the white lines? Okay, now I move it down just a bit. I will reslice it, and support is on. Let's see here. It's supposed to be a straight line, but it's not. See here? It's supposed to be a straight line, but overall I would say 90% look like it's supposed to be. Two hours and 50 minutes printing. Start print. Alright, it looks like the printer is ready for printing. This one is reverse in CAD, and this one is direct printing from CAD Scan Raptor PRO. No post-processing. This hole cannot fit the M4 screws into here. I can't because the hole is too small. See, I can insert it. And the hole is deep inside the pocket, so the scanner cannot catch all the edges of the holes. And this one removes the reflector. See, the edge here has a wavy edges, not straight edge. And this one has a sharper edge, sharp and clean edges. So this one is optimized for 3D printing. There's a much lesser support. It prints almost 1 hour faster than this one. Some of the support cannot be removed from the direct printing from the 3D scanner. Some of the surface that cannot be scanned is automatically filled in the software, and it creates non-flat surface in this area and this area. This one looks much better from the inside. So here is the 3D printed parts that reverse in CAD. Let's try to put it on. So I think that reversing in CAD is still a necessary step for making a good 3D printing from 3D scan. Okay, thanks you guys for watching. I'll see you in the next video.